problem asking about linear regression. A linear regression is a way of finding a best fit line, kind of, for a set of data. So there's different types of regressions we could do. We're going to focus today on linear regression. Here's our problem we're dealing with. We have two people, Kayla and Kevin. They are selling shoes. There's a table of values here, and there's two different sets of data. There's Kayla's data and there's Kevin's data. Our goal is to use the calculator to help us model the trend really of shoe sales for each person. So we're going to eventually have two different lines. And this is a pretty simple set of data. There's only 4 points on each line. Notice our week numbers 1 through 4 is representing our independent or our x variable for this problem. And then our y variables, we sort of have like one set of y's for Kayla and another set of y's for Kevin. The first thing I'd like to do is create a scatter plot of this data on the calculator. And to do that, on our calculator we're going to hit Stat, and we're going to hit Enter under Edit, and we're going to edit our list. Now on my calculator I currently have nothing under list 1, nothing under list 2. Your calculator might have numbers there, and your L1, L2, L3 up here, that might not be showing up. Sometimes the default setting on the calculators start with something else there. So if you don't have a screen that looks like this, what you can do is go back to Stat, hit choice 5, number 5, which is Setup Editor, and then hit Enter, and that should rename your lists as the default names, which will start as L1, L2, and L3 up there. If you have entries in there, you can just delete them out by hitting the delete key when they're highlighted. L1 is where we're going to put our X data. So that's just going to be 1, 2, 3, and 4 in our first list. 1, enter, 2, enter, 3, 4. Alright? L2 is going to be our Y list. So let's just start by just entering Kayla's data. Let's actually forget about Kevin for the time being. Let's just focus on one set of data at a time. Those numbers were 50, 55, 63, and 67. You want to take the extra second and make sure you entered everything correctly, because we do want to make sure we have an accurate list. Now the other thing you want to make sure is that your entries line up. Notice we have 4 entries in list 1 and 4 entries in list 2. For what we do later, you might end up with an error message if you don't have the same values in this list, because in each list. These are representing coordinates, for instance 1, 50, 2, 55, and if they don't line up, then the calculator is going to get confused if you have an x coordinate with no corresponding y coordinate or something like that. So you want to make sure that these match up, otherwise there'll be a problem. I want to get a scatter plot of this data. I want to actually graph this. So we're going to go up to Stat Plot, that's second y equals, and turn on plot 1. So this is where we can graph all of our plots. So under plot 1, first thing I'm going to do is I'm going to turn it on. Then I'm going to make sure that I keep that first option, which is a scatter plot. Notice all the other things we could do. We could graph, looks like a bar chart. We're not going to worry about those just yet. I want to make sure that our X and Y list are coming from the correct part of the chart that we filled in our list when we hit Stat Edit. And remember, our X's were in L1 and our Y's were in L2. If you don't have L1 and L2 in here, you can enter them. Notice L1 is right above the 1 key. So you can type second 1, and that should type L1 in. For the Y list, L2, notice that's right above the 2 key. So if you don't have L2 as a default setting there, you can type second 2, and that will put L2 there. And I like to leave that little square. That's my favorite. The next thing we have to do, if you hit Graph, we can't see our points. So you might be wondering, where are all of those points? I turned on the plot. How come the points aren't graphing? What we're going to have to do is adjust the window. And actually, if you just hit Y equals, notice now plot 1 is highlighted. And you can actually turn the plots on and off from this screen. So notice if I hit Enter and I move away from it, now it's unhighlighted. But I do want to leave it on because we're going to graph our data. And we realized when we hit Graph, we did not see our points. What we want to do is adjust our window so we can see the points. And it's really easy to figure out a nice window because we actually have a table of data right in front of us. We know the points we want to see. We don't care about negative x values. In fact, we don't even care about x values bigger than 4. So I'm going to make my x value 0 and my x max, I don't know, 5. That's really all we need. In terms of y's, the smallest y value I see here in either set of data is 40. So we don't need to go down to negative 10. We don't even need to see 0. I'm just going to go down to maybe 35 as our smallest y value. Our y max, let's see, the biggest y value I care about in this set of data, in either set of data, is 67. So maybe we'll go up to, I don't know, about 70. That'll give us a nice window. Now when we hit graph, I can see that scatter plot of data. Remember, this is just Kayla's data. We're going to start with doing this process just for Kayla. We're going to go through the same thing and do it for Kevin. Notice it does not look exactly linear, because it is just a set of data, but our goal is to find a best fit line using a linear regression for this set of data. What we're going to do, I'm going to quit out of this screen. I'll clear that. We're going to go back to Stat, arrow over to Calc. We want to calculate a linear regression, that's choice 4. Now, what we want to do is tell the calculator which list we can find the x values in and which list we can find the y values in. The x values are coming from L1. Remember, the L1 button is right above the 1, so that was second 1. Now we have to type a comma that's right above 7 to separate the inputs that we're giving the calculator. The calculator now wants to know where are your y values coming from, and that was list 2. If you remember when we did stat edit that first time, we put our y values for Kayla in list 2. That's second 2 right there. Now the last thing I want to tell the calculator is once it calculates our regression, once it gives us the equation of a line, I want it to automatically put that equation into y equals for us. I'm lazy, I don't want to have to write it down and then retype it into y equals. It can actually take this regression and input it directly into y equals for us. That way I can get a graph of that line to do more math with it. So the way we tell it to put it into y equals is once I typed the comma again after L2, we're going to hit vars, arrow over to y vars, hit enter under function, and enter under y1. We can put it into y1 equals, y2 equals, y3 equals, etc. I'm just going to put it into that first y1 equals. Now if we hit enter, we can see our linear regression. It's in the form ax plus b. A was 5.9 and b was 44. So I don't want to answer my question like this. I'd probably say the equation of that line is y equals 5.9x plus 44. Now, check it out. If you go to y equals, it's automatically in there for us. We didn't have to retype it in. Saved us some time. Let's see how good we think that fit is. Now on the screen we can see our scatter plot of Kayla's data. And we can also see that line, that best fit line. It looks pretty good. I can use that line maybe to predict things within our data set, but we have to remember it's dangerous to predict far outside of our data set. What we can do now is go through that same process for Kevin. And then maybe having two regressions together, we can start comparing the data. So let's go back to Stat, Edit, but this time I don't want to remove Kayla's data because I'd like to compare the data sets together. So over in L3, let's put Kevin's data, 40, 47, 56, and 62. And I want to double check, yep, I do have 4 entries there, so the number of x coordinates and y coordinates do match up. Now I can quit out of that screen. I can go to second stat plot, and this time I want to go to plot 2 because I don't want to touch plot 1. Plot 1 was Kayla's data. I want to leave that alone. So let's turn plot 2 on. I want it as a scatter plot. Our x's are still coming from L1, but this time our y coordinates, if you remember, we entered that in L3, the third list that we had. So we have to change that. L3 is right above the number 3, second 3. I shouldn't have to change the window because I already sort of thought about all those data sets when I made the window. Actually, if you want, we can change, the symbol. That's fun. We'll have 2 different symbols on there. Now we can see that the plus signs represent Kevin's data. So we can see his line's going to look maybe a little bit different. Let's find a linear regression for his data. I'm going to quit. Remember, we go to Stat, arrow over to Calc, linreg, enter. I don't want to hit enter again because I want to tell it the x's are coming from L1. I need to type a comma. I have to tell it that the y values are coming from L3 this time. Remember, we put Kevin's data in that third list. Comma again. Now remember, I'm lazy and I want the linear regression to appear immediately into y equals. So I already have Kayla's regression in y1. I want to pop Kevin's regression into y2. Remember, we hit vars, arrow over to y vars, function. This time I want to arrow down to y2 and hit enter. Now I'm going to hit enter for that set of data. There's our regression. I just want to write it in the form y equals 7.5x plus 32.5. And if we hit y equals, there we go. It's already in there for us under y2, just where we wanted it to go. Also, notice that plot 2 is now also highlighted because we were graphing two sets of data at the same time. If we go to graph, we can see both regressions. So one question you might have about this picture is you might say, well, if we assumed that these trends continued far off into the future, there might be a point sort of way over here where those two regression lines intersect. Maybe there's some week, if these trends continue, where Kayla and Kevin possibly sell the same amount of shoes. That's one kind of neat thing about regressions. We have to be careful about predicting because that's a huge assumption if we're assuming that the trends continue. And also we can't even see that. We'd have to adjust our window to find it. But that's just, something to think about. Now, a common problem I see is you go through, you do the regression, everything's fine, then you're doing more math with your calculator later, and you suddenly are getting all these error messages. And the problem that usually happens is it's easy to forget to unhighlight these plots. If you end up changing your list for, maybe another class or for something else you're doing in math, and you forget to unhighlight these plots, then every time you hit graph, your calculator is going to try to plot that set of points that you had there. So my recommendation is once you're done with your regression problem, go back to y equals, unhighlight your plots that you've highlighted, and then you reduce the risk of possibly having some error later, because it is possible that those lists could change. So that's how you do a linear regression. Good luck.